Have you been losing your frickin' frackin' mind because your normal maps look like this? Well, wipe your tears and let me help you, because I have been there. I'm going to start with a quick explanation of the issue. If you have no interest in the technical reason why this appears, then you can skip ahead. I do recommend understanding this stuff if you're going to be chilling in the realm of Substance Designer. It helps a lot. You won't make the mistake again once you understand it fully. After a wee bit of technical background, I'll show you what this looks like in Substance Designer. I'll show you 3 different graphs of mine where I've made one of 3 mistakes. I'm assuming those are going to be the most common ways that it happens. If anybody has another case where it might show up, then please comment below. These are the 3 things that happened to me, specifically. So, as you may have gathered from the title, this happens because of using a bit depth that's too small for the amount of information you're trying to convey. Trying to represent a smooth gradient with too little information. So it looks like this. The characteristics of one pixel can be stored in an arbitrary number of bits. A bit, simply put, is the most basic piece of information or way of storing information in the digital world. If you were to represent each pixel with 1 bit, you would only have 2 possible values, 1 or 0, usually black or white, which you can see here, 1 bit, 2 values. This is what a gradient would look like from black to white. Using more bits would then allow you more values, because the amount of values that an image can store are basically the amount of combinations that you can make with the amount of bits available per pixel. So if you have 2 bits, you can go 0, 0, 0, 1, 1, 0, 1, 1. So you have 4 combinations, which would be 4 values that you can store for that particular pixel, or for each pixel basically. For 3 bits, you can do 8. For 4 bits, you can do 16. Obviously, if you were trying to create a smooth gradient, you wouldn't get very far if you were using 1 bit, 2 bits, 3 bits, 4 bits, even 5. But 8 bits works pretty well, 256 values when you're in grayscale. When you're in color, you would have 256 per channel. So RGB, red, green, blue, and it ends up being 256 times 256 times 256, which is 16,777,216 color combinations. So a little bit more. So you get quite far with that. But there's specific situations where 8 bits are not enough, and that's with normal maps and height maps. That's where you start seeing banding, which is what we're talking about. So for regular photos and stuff, you usually would have 8 bits or anything. If you export something out of Photoshop, it's 8 bits unless you go to export copy, for example. That's the only way to export it as a 16-bit image, apparently. Correct me if I'm wrong, but that's the experience I've made today. So let's look at this in Substance Designer. So I've experienced 3 possible ways for this to happen. I'll show you 3 different graphs. So the first one is using bitmaps, so importing images that happen to have a bit depth of 8, which, as I said, is usually enough. But if you take one of these 8-bit images and they kind of go in through the graph and end up changing the bit depth of your entire graph, boom, you got a problem. So even though these are 8-bit images, you can still go in and change the output format. You would double click on your node, output format to absolute, and then change it from 8 bits per channel to 16. This isn't going to magically enhance the quality of that image. I mean, it's still a piece of crap, but it will at least not influence the inheritance of 8-bitness throughout the graph, so you won't have any issues there. The second way this can happen is if you use a blend node with nothing connected to the background input of it. So apparently blend nodes default to 8-bit if there's nothing going in. This graph is ridiculous. I think I was trying to follow some sort of tutorial a few years ago. And I don't know why I did this, but for some reason I took my height information, which would have been potentially completely fine, And then I decided to put it through a blend node with a black background. I don't know why. Whatever, it's stupid. So your solution in this case, well, in this case, obviously you wouldn't even use the stupid ass blend node. But if you needed the blend node because you maybe are using an opacity mask or something, then you can just go in and override once again, going to 16-bit. So to showcase the third way this can happen, we're going to look into a graph that I also made a long time ago. And this happens to be a fuck-up inception. So if we look at our normal information, we can see here, there's our banding, ooh. Even though it says C16, by the way, this just means that at some point we used 8-bit information, then somehow ended up switching to 16 bits, but obviously we didn't enhance that information or smooth out the gradient that happened because of the 8 bits. So if we start looking around for the culprit, I just start moving around until I find an 8. So 16, 16, here's an 8, okay? So where does this 8 come from? Here you can see it switched to 16 because we input something into the background of a blend node that was 16 bits. So this is exactly where that happened. And if I keep going, this actually comes from another graph, because for this project I was using a specific backdrop for everything based on a tutorial by Malakir. I can link it or something around here because it was really cool. So if I go in there, or I could right click on that node and open reference. If you see here, we end up with an output of C8. So again, color 8 bits. And if we go backwards, okay, all of these are 16 bits, so they're not the problem. But everything here stems from a uniform color. So we put a uniform color, which defaults to 8 bits per channel, into the background of a blend node. So we have 8 bits. It's basically the same issue we had before. So uniform colors, if you're going to put them in the background, you also would probably want to, especially if we're talking about normal information, if it's somehow going to influence your normal or height information, switch to 16 bits. So now everything is 16 bits, output 16. If we save it and go back to the stone wall, we fixed our banding. So basically, if you find this problem in your normal maps, you just have to go take a look at the rest of your graph and find out where it happens. Because even if it says that you have a 16-bit image going into your normal map, apparently you can't trust that. Okay, well, I hope that helped. If you have any more ways that this can happen, then please write them in the comments. I'm really curious, and it would help other people, I assume. But even with this knowledge, you pretty much can deal with any situation because you know what to look for. So thanks for watching. I wouldn't even be that mad if you decided to subscribe and maybe like my video and maybe comment. Like it'd be fine. I wouldn't even be that mad, you know? So just, you know, I'm not watching you. It's fine. You just do you. You just do you. Okay, bye.